Hello, everyone. Welcome to our April 10th webinar. I hope you enjoyed the eclipse a couple days ago. With us today, we have Graeme speak to talk about authentication and passwordless authentication and reinventing web security. But first, a couple of announcements. First, starting off, if you are hiring or looking for a job, check out sfisaca.org. And if you have a job to post, email education@sfisaca.org and we'll post that to our website. Moving on, if you would like to be like Graeme and speak at one of our webinars, again, reach out to education@sfisaca.org. We will line you up to present to our chapter. Next, we are on LinkedIn. So if you're not following us, we have announcements for webinars, events, anything going on with the chapter. Feel free to follow us on LinkedIn. Right now, I think we're up to about 850 followers. So join the crowd. Moving on. So CPE, we are recording your time on session, so that Zoom link that you received is extremely important as far as tracking your CPE for attendance. Certificates will be provided through the ISACA.org website if you're a member. We also post this to IST squared, so your CPE will be processed there as well. And CPE certificates will be processed, like I said, through the ISACA.org website. And if you're not an ISACA member, just email education@sfisaca.org, and we will send you a certificate to prove your attendance for CPE. And then on another note, Graeme has volunteered to share his deck, so he'll be getting that as well after the presentation. And moving on to announcements. So in 2 weeks, we have forecasting data breaches with Dr. Lee and Michael Stoyanovich. So join in 2 weeks. We'll post that soon. And to save the date, moving on to April 30th, we are almost filled up. So if you have not registered for our joint conference with the SFIIA and us, SFI-SACA, do so immediately so you're not locked out. But moving on to today's webinar, like I mentioned, we have Graeme speak with us. Graeme will be talking about reinventing web security, 3 times intelligent new approach to unlock secure password access to web login portals. Quick bio on Graeme. Graeme is a veteran entrepreneur and innovator with over 25 years leading teams through pioneering cloud computing and cybersecurity. He is now focusing on tangible business problems through deep technical insights, where those solutions can be scaled globally for commercial success. Graeme holds 14 patents and is currently in development of 25 technologies, and he's a founder for BankVault. So without further ado, I will hand it over to Graeme. Thank you.
Thanks, Randall. Hi, everybody. So I run a cyber innovation team, or an innovation team. We're developing new cloud computing platform technology. And what we did in 2015 was literally take that technology, which was pretty cool, and actually applied it to a different problem, which was bank accounts were successfully being hacked despite having two-factor authentication. We basically rebranded ourselves as BankVault Cybersecurity. We've now got 14 patents, probably 25 innovations, 5 products in market. And tonight I was actually going to announce a new product, but we've actually decided to file another patent, and I can't describe it in detail tonight. But if you guys keep connected with me, in the coming days, we'll reveal all, and it's really cool. So what I'd like to do is just dive straight in and just give you a demonstration straight up. And I can do this straight off my phone. If I just hold this up here, this is just a website. It could be anything. This happens to be an accounting system. And I'll just go through a thought experiment. Imagine that the people that run this accounting system, it's an online SaaS platform, deployed our master key technology this morning. So normally deploying passwordless authentication is a really significant project. It will take at least weeks, typically months or longer. But this was literally 3 to 5 minutes. And when I go to log in, I mean, there's my normal login. Nothing's changed. If I go in here, I'm just going to enter my existing username that I do every single day. I'm going to go up here now and enter my password. It's the same thing I do every single day. Everything's the same, except you might have noticed that in fact the keyboard is now white. It was black a moment ago. Now, this is deliberate. This is actually an illusion. There is no keyboard. This is a photograph. And it could be pictures of fruit, it could be Chinese characters, it could be anything at all. What we're actually doing is setting up encoded cells on the screen. So when you touch the cell above the photograph of the letter A, instead of generating the letter A, which is 1 character, I'm going to generate perhaps 48 characters. And the only place in the universe that can actually interpret this is the web server that set up the security secret a second earlier. So it becomes a character in the web server. It echoes an asterisk back on screen. If I keep touching the screen here, you'll see asterisks appearing. It looks normal. Finally, I'm going to press login. Transmits my username. Sorry, there is no password. It's already at the back end. I'm also going to generate a unique device signature for the phone as a second factor. I'll pass that through. The system authenticates if I've got it right and logs me in. And that's the last time I'll ever do this. If I ever come back in here again tomorrow, I'll just hit refresh on this page. You'll see it recognizes me instantly. I tap to log in. We're done. 2 factors of authentication in 1 step, nothing installed and no setup. If I'm on a workstation, let me share my screen here. Oops, sorry, there we go. Okay, can I just check, Randall, are you seeing my QR code on the screen?
Yes, Graeme, we are.
Great, all right. So what I'm going to do, I mean, I can continue logging in each day as with my usual username or password, but let me scan this QR code with my phone camera. I'll turn this around so you can see this. It's recognized me. I tap, authenticates, and logs in. And one more quick demonstration. Another site here. This is actually one of our customers. They're a Boston-based financial services group called Trellis. If I go into the login portal here, I've got an account on this system. We've actually got our data room here where we're capital raising. If I scan this, it's a slightly different experience this time. And I'll just add, I'm normally in San Francisco, but tonight I'm actually in Australia. It's about 3 a.m. in the morning here. So there's a slight lag between here and Boston, but you can see it recognized me straight away. If I tap here, it's now going to ask for my biometrics. Now I've set this up now to take my fingerprint, it could be my Face ID, it authenticates and logs in. That's 3 factors of authentication. Again, nothing installed on my phone. So let me expand on this a little bit now. And we'll go into a few side stories because what I'm really interested in doing is kind of sharing the story of the innovation and how we created this technology, which we're so proud of. This is very, very cool tech. We call this particular product Master Key. It's invisible from the user. There's no software, nothing to set up. And one of the things that we realized is that when you're trying to sell cybersecurity to the head of security of an organization, he tends to be, or she tends to be, the most conservative, risk-averse, and therefore change-averse person in the organization. Security is an important issue. What we found, though, is that in Silicon Valley, 9/10 of the reason that we hook people's attention is actually not for security. It's for a better user experience. If we can provide seamless access, it's going to actually increase engagement. Stronger security, that's obviously going to build trust. And we're actually going to reverse login abandonment, which is a major issue for most online services. So we've actually shifted left. We're actually presenting initially to everybody that's involved in actual growth. The CEO, the CFO, the CRO, the CPO. It's a slightly different equation. And of course, it does tick the box for security. I'll just mention the team. Just a headline here is one of our shareholders is Whitfield Diffie. You might know of the Diffie-Hellman key exchange, which underpins almost all encryption today. So he's one of our shareholders. What he loved about our solution was the seamless nature, which can actually provide mass engagement. So the problem, most cybersecurity attacks target the end user's device. It's very difficult to get to servers which are behind firewalls, but end user devices are all there, and it's very simple. The goal is identity theft, is to actually capture your credentials to online services. It's very simple to do. when you see somebody entering a username password, you see asterisks. These asterisks are just a mask for the person sitting in the chair next to them. Any software sees this as clear text. If you're using a password manager, when your password manager loads your encrypted password into that web form, it's no longer encrypted. It's now clear text. It's just sitting there. You haven't pressed login yet. So if there is a man in the browser, it intercepts it instantly. There's actually nothing that the password managers can do to stop this. It's a fundamental design flaw with the way browsers work. And this was the thing that we actually set out to actually solve. So the solution to date has been two-factor authentication. It's a really good idea, but you do it as a last resort because it is such a friction point for users. Even if the product is free, it's expensive to deploy and support. And it's not infallible. It's literally a second hurdle in series. If I've hacked your browser, my JavaScript's been there, according to Semantic, on average for 10 months before I sting you. In that time, I've learned everything. I certainly know your login credentials to your bank account. I'm now one step away from tricking you to revealing your second factor, which I can do because I've got control of your browser. It's a little social engineering. And if I get it, the reputational consequences for everybody concerned can be catastrophic. So the solution to this is passwordless authentication. As I said, we're providing seamless access, which is increasing engagement. Strong security is going to build trust, reversing login abandonment. This is actually a business driver. It's a growth accelerator. And it's better security as well. The problem is it's a major implementation project. If you look at all these are a short list of other solution providers on the market. I mean, all these solutions work. And these are all billion-dollar companies, and this is just a short list. All of these solutions require a significant project. You're going to change the way you're identifying a user. You've got a data migration to go through. You need to handhold and educate the users to download, install, and configure software. And you need your A team, your top guys, overseeing the entire project because this needs to be done properly. If anything goes wrong, the day you go live, it's like changing the undercarriage on an aeroplane while it's in the air. And you can't afford to be offline. So we've actually solved all of these problems. So the solution here is invisible to the user because we're simply harnessing the browser on the user's mobile phone. There is nothing to install. It's deployed from the front face of the web server. So all users get this instantly. And there are 3 component technologies. The encrypted invisible keyboard, you saw a glimpse of this. This can either capture the credentials of an existing user or generate the credentials for a new user. We then retrieve these to create the passwordless experience. And this is multi-factor authentication, but done in one step. It's invisible to the user. So on a mobile phone, it recognized me and simply logged in. On a workstation, we want to harness the browser on the phone. That was the purpose of the QR code. Scan it with your phone camera. Your phone's browser connects to the same web server session, authenticates, and logs in. There's nothing installed on any device, and there is no setup. So I wanted to do a little demo now in a little bit more detail. I'm going to use an analogy, well, not an analogy, I'm going to actually use a live demo of an online system called Moodle. Moodle is a learning management system. One of the reasons I'm in Perth, Australia at the moment is because Moodle's head office is here about half a mile from my office. And these guys made the decision about 20 years ago to open source their software, so it's free. They now have 160,000 schools and I think 410 million registered users, although most sites don't actually register, and it's considered the numbers could be actually 3 times this. It's absolutely massive success. We've actually put our module or putting our module into their marketplace. Any of these institutions can deploy our solution in probably 3 to 5 minutes. So let me quit out of here and I'm going to go in here and do a little quick demo. So imagine for a minute that the organization makes the decision on Friday afternoon. They've looked at this, they've realized there is no technology risk. I'll come back to that. And there is no security risk. I'll come back to that too. So if that's the case, they could actually deploy straight away, big bang. So they make the decision, they install the module, it's literally click download, install, and activate. We'll come in Monday morning. And if you're on a mobile phone, as you saw on my mobile earlier, there is no difference. It's just a normal login. I would log in as usual. But I'm sitting here in front of a workstation, and on a workstation, I've got a QR code. But it's Monday morning, and I don't have time to think about it. I'm going to ignore this. I'm just going to go back to the username, password, log in the same as I do every day. Tuesday, Wednesday, same routine. It's not until maybe later in the week that QR code's been there all week. I trust the institution, and there are 3 words: scan to log in. So, Randall, are you there? Are you talking?
I'm here,
Randall?
but you're talking, Graham. We also have a question. I don't know if you want to handle this now, but
Yeah, sure.
what happens if your phone is lost or stolen? Or I guess we could raise this up to, what if one of your factors of authentication is not consistent, or you lose it, or?
Yep. So yeah, that's a good question, and it just depends what the back end organizational rules are. You can, in this case here, you can see I don't need my phone. I can just log in with the username and password. I'm not locked out. But if an organization lifts up the security, you've been here for onboarding with this for a while. Now we want to raise the security level. Literally, there'll be an operational switch, and you flick to this, and you're forcing them down a particular channel. If it was a financial institution like a bank or something else where it really counts, or medical records, yeah, you damn well want to make sure security is really top notch. So if you lose your phone, yep, you've got to go back and actually set up again, probably prove who you are. But this is not our technology. This is actually the organization's implementation rules. It's what they want. I'll give you a little demo on this one here. I'm going to scan this with my phone camera. And I'll hold this up on my screen. It's actually, I've done this before, so you get the point. It's already recognized me. I'm just going to tap this. It'll authenticate and log in. At the back end, what it received was encoded, encrypted information, which honestly nothing would interpret it, but it had the security secret, was able to interpret it. What it interpreted was a username called hello, a password of world, and there's the device signature of my phone. Two-factor authentication is something that I have and something that I know, and I captured that without installing or configuring any software. If security was really, really paramount, I can also implement my proof of presence, which is the 502 standard. And it's very simple. I literally flick a switch and we're done. Normally implementing 502, passkeys is a significant project. I'll talk more about that in a moment. So what I'd like to do is actually give you all a little experience of this in your own hands right now. And I've got a little mock-up here. If you like, you can log into the ISACA website. It's not the real system, but you can actually do this. If you want to scan the QR code of your choice with your own camera now, what it'll do is literally take you to a demo. And on that demo, you can actually type in any username you like. When you go to the password field, you'll notice it will change. You'll only ever use that keyboard once, so even though it might seem a little bit different to what you're normally used to, it's fairly intuitive. Just press save and log in. You'll see the username and password that you've entered. It's been captured. And it's been captured in a decentralized protocol. I'm going to explain this in just a minute. And then down the bottom, there'll be a log out button. If you press the log out button, it should go straight back to the login screen and instantly recognize you and ask to log in again. You just press OK, it'll log you straight back in. This is incredibly simple to use.
Sure. Another quick question for you, Graham. There is what if you don't have a smartphone? I guess I don't know how many people don't have a smartphone anymore, or, the
Well,
millennials are going back.
it literally goes back to that. So I'm moving around here. It literally goes back to just enter your usual username and password. A key point I want to make here is there is no single point of failure. In the worst possible situation where, for example, the internet is down, master key is just not working, there is no QR code there, the users can still log in with a username and password. Literally, if that's what you're enforcing and there is a problem, you need 3 lines of code to route around that and just present the username and password again. So the user is never locked out, but it depends on the business rules that the organization wants. Like a school running Moodle might not care, but a medical center probably would. So, yeah.
And have you seen any best practices, or what do you recommend as far as the process for this?
The process, yes, that's a great question. So the process for this, we want to basically have adoption by osmosis. If you've got a site with hundreds of thousands of users or millions of users, you can't afford the change management. It can be a complete showstopper. So what we recommend is basically providing it here as an option. You're not forcing it down anybody's throat. It's literally an option. And what you can do is encourage people over the next few weeks to actually try it out. They'll talk to others, they'll hear about it, they'll get curious, they'll just try it. And then you actually up the ante. You flick the switch at the back end and you'll go to this. But you might leave an option down below to go back. So they're not actually locked out. You're channeling them down a particular path. If they click the bottom link, they're just going back to this. And there'll be a third stage at which you actually know you are now serious. You're ratcheting it up again, and you don't give the option. You're literally forcing down this particular path. That's what we see as best practices. And it's important when you're first deploying also to not enforce a rule, because we're also supplying 2-factor authentication now. So a website that typically has only had a username and password now has the option of using 2FA. But sometimes users are going to get a surprise. They don't know quite what to do. They're going to fumble on the phone and they're going to get their password wrong. And if you've got a password rule in there that says, or sorry, a login rule that says you're only going to allow 3 logins before you lock people out, you can actually tie your shoelaces together and create a problem for yourself. So we'd recommend relaxing that rule during the onboarding process. After people are using the system, you then ratchet it up. You do it step by step by step, gradually. It's like boiling a frog. You do it gradually, and everything works smoothly. So let me go on now, and I'll explain how we did this. So the heart of the system is this invisible encrypted keyboard. When you went to the Moodle demo there, you got a normal login screen. You entered your existing username into the field with a normal keyboard. Everything is normal. You would normally do the same with the password field. But what happens when you touch the password field, we invert the architecture. Your keyboard is replaced with an image transmitted from the infrastructure. As I said, this is just a photograph. What we're actually doing is setting up encoded cells on the screen. You touch the cell above the photograph with the letter A. This time we're going to generate 32 characters. And the only place in the universe that can interpret this is the web server that created that security secret a second earlier. So it's buffered in the web server. And it's ultimately where it's got to be. The web server echoes asterisks back on screen. You keep touching the screen, you keep getting asterisks, and there is nothing on the phone that can ever intercept or interpret what you've done here. No recording, nothing. Finally, you press login. It transmits the username, merges it with the password. We also create a unique device signature for the phone and pass that through as a second factor. Now, we built this product about 4.5 years ago. What we've learned is that trust accounts were having their bank accounts actually hacked despite having 2-factor authentication. It was actually getting fairly public. There's so many examples that you could actually read up online. So it's a serious issue. If you're a lawyer, if you're a property escrow agent, if you're a real estate agent, you got a trust account. It was a seriously It was a bleeding neck problem. You had to do something about it. Our hypothesis was that if you could never intercept the password, that would fundamentally change the dynamics of cybersecurity. And we were right. In Australia, two of Australia's largest banks got right behind this, and we got escalated up very quickly. I remember having a meeting with the head of the CBA, Australia's largest bank, and he said, "This is fantastic." But he said, "Unfortunately, we've got 20,000 IT staff. We can't afford to buy it for startup. So you need to sell this to someone like Dimension Data, and we'll buy it off them." And about 20, 30 minutes later, when I was leaving, he said to me, "Graeme, you probably need to also know that even if we're desperate, our processes here are going to probably take us 3 or 4 years." That was the moment I realized actually banks are no longer our target. There is no way a startup can survive with nothing for 4 years. So what I did is I actually took this product and used it as a building block. And there is a very funny story. I might come back if we've got time at the end as to how we actually came up with the idea for this. But basically, what we did is we realized there was a way of solving the password manager issue. So the new product we call MasterKey. It's a decentralized protocol. It's not a blockchain. By decentralized, what I'm saying is that there is actually 3 security secrets that are generated behind the scenes. They're never visible to anybody. They're never released. They can never come together. What we actually have here is an intelligent protocol. It works one way. It only works if it's initiated by the user's mobile phone and perhaps their fingerprint, Face ID. It can only be resolved by the original web server. And the secret of this is this infrastructure in between. There's actually 2 separate pieces of infrastructure. So what happens if we give you a module? If you're running a Moodle site, you can download this module. It's free. It's open source. You can see what it's going to do. And it's literally a cosmetic change at the front face of the web server. If it's not a module, there's about 20 lines of code. You could actually code it yourself. There is no changes to the back end. Whatever back end systems you have remain fully intact. No changes. So this module does 2 things. It first detects if you're on a mobile phone or a workstation. If you're on a mobile, it's happy. And if you're not, it presents a QR code on the workstation. And the purpose of that is for you to scan it with your camera, and it will connect your phone to the same web server session. So the baseline here is the mobile phone and the web server. The second thing it does, every time it generates a login page, it's going to generate some random strings of characters that we'll use as temporary security secrets for this session. Now, the way a security secret works, part of it's private and part of it is public. The public-facing secret is what encodes the mobile phone screen. This is where we were 4.5 years ago. What we now do is we get the mobile phone to do the same process. It generates some random characters and encodes the mobile phone a second time. So the mobile phone screen is now double encoded before the user's intent is ever registered. And there is literally nowhere in the universe no single place in the universe that can interpret this. So you touch the seller of the photograph of the letter A, we're going to generate maybe 32 characters this time. And we can actually store that anywhere. Before we store it, we'll also encrypt it. So we have encrypted and encoded data. Now, we haven't invented encryption or encoding. Those techniques are really well established. And we all know that with current technology, you would need billions upon billions of years to decrypt this. And if you succeeded, you'd have contextless, meaningless encoded data you could never use. Your phone comes back tomorrow. It remembers it's got a data record. There's only a few hundred characters. There is no PII, personal identifiable information. It will take that record out of here and hand it to a separate system. This system can receive the mobile phone security secret and start deciphering. But that data is still encoded with 2 other secrets. A little bit more handshaking between the web server and this system here, and it passes the information back bit by bit. The web server applies the original secret for the session, interprets it, and becomes a character. This happens in milliseconds. We do this a few times, and we end up with 1-factor authentication, the username and password. We also pass through the device signature of the phone as a second factor. you saw me use my fingerprint, 3 factors of authentication. This is the FIDO2 standard, or what Google, Apple, Microsoft are now calling passkeys. We are FIDO compliant. We can bring in the GPS coordinates. And 18 months ago, the Australian government flew me back from San Francisco to attend the Indo-Pacific Maritime Defence Expo in Sydney. And we got selected to present as one of the earlier stage startups, and we won Best Overall Innovation. Out of that, we got a relationship with the French aerospace defence contractor Thales. They gave us a machine learning code that runs in your smartwatch that will tell us that Randall is wearing our smartwatch, not Graeme, and he's alive, and it'll do that in 30 seconds. It's a really cool tech. So we can go to 5 factors of authentication. We could go to 6. When we actually started looking at the addressable market, unless you're in the Pentagon, no one's asking for 5FA. It's only been 2 banks who asked for 4FA, Bank of New York Mellon, Bank of the Western California. This market is as thin as a wafer. The world is actually going FIDO2, passkeys. As I said, Google, Apple, Microsoft, and others. But FIDO has problems. It's very complex to integrate at the back end. It's a project. And when you deploy this Monday morning, every user's mobile phone is different. Every user's capability is different. And there will be a portion of your users that are struggling to set this up. And you have actually no means of shadowing their mobile phone and helping them. You have an impossible support problem. Easy if you've got a small office. Imagine you've got 100,000 users or 6 million users. It can never happen. The FIDO Alliance wrote a white paper in May 2022 where they acknowledged this. And they said, look, for mass adoption, we need a more seamless onboarding experience for users. That's what we've achieved. So if we look at the actual addressable market, almost every web portal on the planet today uses either social media or username passwords. Social media came in because passwords were such a bad idea. But this standard called OAuth is often not implemented properly, leaving security breaches. And an organization called Salt Labs published a list of breaches about 6 months ago. And a lot of very large organizations with hundreds of millions of users have exposed their members' credentials. It's a serious issue. A lot of people don't trust social media. What happens if Facebook blocks your account? Do you really want Facebook knowing everything you do? And of course you don't. So what we're doing is we are fortifying the user against the weakest part of the network, which is their own device. We're providing seamless access, which increases engagement. We're uplifting this to multi-factor authentication. And depending on your environment, you can actually implement this anywhere from 3 to 30 minutes. The addressable market for what we have here is literally every web portal on the planet. If you can deploy this instantly, you're going to have an immediate return on investment. There is no infrastructure changes at the back end. There is no client software, no user setup. And so the change management project, it's never absolute zero, but it does trend towards nil. So in a typical site, we let anybody have access to this. That's our model. It's free to start with. You could deploy this. If you set aside a few hours, it's really all you'd need. And you could maybe just put some dummy data through that has no consequence for testing. But if that works, give it out to a few choice users for feedback. And if the feedback is positive, maybe mount a small pilot project. If the pilot's going well, expand it and just keep growing it until everybody is live. The actual technical work between each of these steps is exactly zero. It's purely who do you give access to that portal. Or what you might realize is, in fact, you could afford to go big bang. As I said in the beginning, there is no technology risk because there is no single point of failure. The users can always log in. And there is no security risk. This is the user's normal input. Only we've abstracted it away now. It's now controlled by the organization's web server. The user never enters it again through the weakest part of the network. And this also ticks the box for a very important term this year called zero trust. Nobody needs to trust the end user's device. It doesn't matter if it's compromised. Nobody even needs to trust BankVault, us. The programmer doing the work here will see within 2 minutes, he's generating the security secret. He never releases it. And without that, nothing works. The organization is totally in control. So the focus for this technology is SaaS companies or web service, enterprises, government departments with a web login portal. It can be adapted to mobile apps connecting to a web service. For us, it's a horizontal place right across the board. Anyone from a news media outlet with millions of users, obviously medical center, telcos, through to school. I went through a few of the adoption drivers. One of the interesting ones that we discovered was actually with an online business newspaper. They didn't care about security. What they wanted to ensure was seamless access for the users, because if a subscriber can't get access and can't recover their password for whatever reason, they lose several $1,000s per year from that subscriber. It's a serious issue. What we've discovered is actually we do more than that. We actually stop credential sharing. They can no longer share the business newspaper around the office. Everybody needs an account. That stops revenue leakage. And for a SaaS company selling a SaaS service per user, that's actually a major driver. We started looking at the obviously, everyone looks at the top end of the enterprises. I mean, one of our targets was Canva. I actually know the founders of Canva. They're friends of mine from Perth. Currently have, I think, about 130 million users a month, and we look to be a perfect fit. It's a long sales cycle, of course, because the founders are not technical. They have a large team now. So I think it's a $20-30 billion company. As a small team, we don't have the resources to last the distance with a long sales cycle. So we've been outsourcing, just partnering with others. Our attention turned to what the market is called the long tail of the market. These are all the small to medium enterprises that collectively make up the bulk of the market. And these smaller organizations don't have the resources to spend 4, 6, 8 months implementing a new security solution. The trouble is, how do you reach them? That's always the problem with targeting the long tail. But what we discovered is these online marketplaces. These are essentially self-service portals. So what I'll say is that the infrastructure that we've created is really cool. It will scale to 1 billion users. The technology, if you can imagine, you've got a mobile phone connecting for a few milliseconds. We could set this up so there's maybe 32,000 concurrent phones connecting. That's according to the manual. In fact, we've built up to 1.5 million concurrent connections per machine. Those we can set up a high availability cluster. We can spread these around the world. So the infrastructure scales massively, and it costs next to nothing to run. So we can allow anyone to test drive this for as long as they like, for free. We don't guarantee anything. When they want to go live, they want some service level guarantees, and that's when we actually ask them to start paying, and we guarantee things. We started looking at Crunchbase. Crunchbase is an index of over 1 million tech companies, and the majority of these have a web login portal. 2 years ago, we had to explain what passwordless authentication is. But with Google, Apple, Microsoft now having it on their own platforms, everyone now knows this. And so there is a search on for these solutions. So what we have is actually a communication problem. How do we let them know that we're here? Yeah, we're a technical company. We're not a marketing company. That was why we decided to go for this, what is called a product-led growth model. We let anybody use it for free. When you want to get serious about it, that's the point at which you want some guarantees. That's when you start paying this. The demo I gave you at the very beginning was with an online accounting system called Odoo ERP. This is a company based out of Belgium. It's an open source ERP system like SAP for small business, currently with 300,000 sites worldwide, for about 10 million users. We are the only passwordless option in that marketplace. Any of those organizations can deploy this in 3 to 5 minutes, initially for free. And our path to market is really just, reaching out to the service providers, giving them something completely new for their client base and the option for new revenue streams. And we've de-risked it from the technical point of view, no technology risk, there's no security risk, and we've removed the business risk by making it free as well. It took us about 2.5 years to work out how to crack that nut. Moodle then took us 4 weeks. And there are dozens and dozens and dozens of other marketplaces, which we estimate are each going to probably take about 4 weeks. Our competitors' solutions can't do this as efficiently because they've got fairly hefty integration at the back end, and every user has got to download, install, and configure software. So we're simply more efficient. We're also putting this into the developer framework. So if you're a developer, you get it free. You can spend all day looking at one of our competitors. They'll give you training videos, code generators, examples, and you'll be there for days and days and days because this is hard. Or here's a module, just validate your email address and it's free. You'll be up and running in a few minutes and you'll spend the rest of the day worrying about what colors you have on screen. So that's it in a nutshell. Our goal is to make this the trusted default for web security. The way that we've priced it in the market is an experiment. We're still trying to work out what the pricing should be. I've discovered one of my competitors is 40 times more expensive than us. So probably we can change things around a bit. We're still kind of learning the market. It's a very embryonic market and it's all over the place. What we know is that we've got a really strong competitive advantage. I'll probably pause there, but I want to also just show one other thing quickly, and then maybe we pause for questions. If I get out of here, one of the other products that we have, and I said we've got a number, this was one of our starting points. And we actually kind of deal with Equifax back in 2017 for this. Equifax was going to sell this into their client base. Literally, it got frozen 3 days before launch because they suffered the largest hack in US history at the time, 163 Americans losing all their private data to the hackers. So the reputation went low in the gutter. But this is very, very cool tech. I'll just give you the example here. How do you know if your computer is being hacked? You'll never know. So if you're doing something like banking or trust account banking or something where it is really critical, don't use your laptop. Go down the street, buy a brand new computer, use it once, and then throw it away. That's essentially what we're doing, but we're using the cloud here to do this. If I click a button here, what we're going to do is we're going to build a virtual machine. The build of that machine actually happened in 1 second. That machine is also invisible from the internet. I'll also add that we did this when Amazon was taking 30 to 40 minutes to build a new machine. And that patent is now granted worldwide, backdated for the last 10 years. And we think the patent's probably worth a lot of money. So pristine new machine. It's never been existed before. It's invisible from the internet. And I can now do whatever I want. I'm going to go up and I'm going to launch Firefox. Firefox. Okay, someone's connected. Good, that's what I wanted. I'm not sure actually. There we go. Okay, I'm going to go to say NetNav. There's a bit of a lag. This is just a lag on the internet. I'll go here to netbank.com.au. And I'm just going to log in with my normal bank account number, which is 1, 2, 3, 4, 5, 6. I'm going to go to the password field, but I don't want to enter my password through my local machine. As I said, it might have been compromised. But you can see here that I've got a QR code. Now, a few guys would like to just scan that QR code. I'll wait for a moment. And all it's going to do on your phone is load up an image of a keyboard. Now, as I said earlier, this is an illusion. It's just a photograph. There is nothing on your phone that can actually intercept this. Okay, for those guys that have tried this, okay, I'll just stop it here right now. Going to bring this back up again. just type whatever you like with that keyboard. And what you don't press the enter cut just yet, and you'll see asterisks appearing. So the only place in the universe to converge, somebody press enter. I'll put the, yeah, you can keep typing. Don't hit enter. The only place in the universe to converge what you're typing with your keyboard and what I'm typing with my keyboard is this virtual machine that has never existed before and is invisible from the internet. That's it. Log in. There is no single attack surface. I could also use this virtual machine for opening up emails with, hot links to things that could be dangerous. I could open up a virus. This machine is effectively built on the other side of the moon. Can't do anything. It's a stream of pixels into my browser. You can't hack a stream of pixels. The browser is effectively just a dumb television screen. I actually can integrate this. I can actually drag and drop things in here. I can get things out of here. But we wanted to make this actually bulletproof. It's effectively a graphical proxy of a virtual machine. And if I log off, whatever we were doing there evaporates without trace. If I log in again, it was a completely new machine, different address, fresh beginning again. So whatever you're doing here for your business, you're secure, anonymous, and untraceable from any malware or hack on your network. I might stop there and happy to answer any questions.
Sure. Thanks, Graeme. Thanks for that visual. So a couple of questions came in earlier. If your default back to login password, if you default back to that, could a multi-factor token be enforced if you're just doing the username and password?
Yeah, look, I
QR
think
code?
you could use an existing, if you've already got two-factor authentication, you could add this in. Yeah, they would work. But I think you'll find in the end, actually, you probably don't need it. If we can do the two-factor authentication without your user having to do anything, it's an advantage. It just simplifies things. I think the other one will become redundant pretty quickly. But yeah, there's no reason why you couldn't do that both.
Okay. Would that be susceptible to a brute force attack in that case? Or
No.
what would your second FA be to reduce that likelihood?
So what we're doing is, as I said, the demo I was giving was we're providing, if you want, three factors: the username and password credentials, which are captured in a way that can't be intercepted. We're using the device signature of the phone. It has to be that particular phone. That can't be intercepted. And we can bring in your biometrics, your proof of presence. So we can ratchet it up to whatever you need. Obviously, these are implementation details, so a little bit more. But I gave the demo at the very beginning where I was using my fingerprint. You saw that. So that was bringing in three factors of authentication.
And a similar question from Anjali here. In essence, you still use password to establish credentials, and the password list is now okay next time you log in. Still need to follow policies. So do you enforce any password policies as far as complexity? Would you recommend that as well?
So we don't. We are effectively just a blind conduit, like an interface to whatever the back-end system of an organization is. We're just done. So we cannot interpret anything that's going through. We don't know who you are. The web server at the back end, the authentication system is going to determine whether you're a valid user or not. Now, you can change that. There's more that we could do, but the product I've just showed you here tonight is really a very, very simple interface that provides seamless access, increasing engagement, better security, but we're not presenting ourselves as identity and access management. Identity is actually controlled by other people, by other systems. We would love to do it, but we haven't done it yet. So we are kind of the interface to whatever IAM you're actually running. So we haven't done it yet, but we want to be able to, it's on our roadmap right now to integrate this with Google Firebase, with Amazon's Cognito, and with Microsoft Single Sign-On. Each one of those will open up a completely new universe for us. It's high on the agenda.
So you mentioned single sign-on, and this is a good lead into the next question is, how can this be implemented with different apps and databases to become a front end for like a single sign-on type application?
Yeah, it's all in the fine detail. the broad statement was, of course we can do it. Yeah, let's go look at the fine detail. It's a little more involved. We've got a lot of businesses actually asking for this at the moment. We're a little under-resourced. We're effectively a small R&D team. I've got to say, I'm actually thrilled. Just today, we have actually secured some more funding, which I'm just so happy about. And hopefully there'll be some more investment coming in very shortly behind that. So we will be able to build up the team. But we're kind of working a single file, small team. So we want to do all these things and we can't do them in parallel as we'd like. So yeah, it's just steady. We've got as I said, we've got another really, really brilliant product that I would like to have been releasing tonight and showing you all as a launch. Unfortunately, the patent attorney hasn't finished his work, so I can't mention it. We're knocking on the door. It's right there. I'll show you right now. And it's brilliant. It's like completely instant. Yeah. Can't say more.
Yeah, we'll look forward to that. So another question I had is, as far as, zero trust is kind of the buzzword du jour. How does your application interface with what people are doing with zero trust internally with their networks, or does it?
It doesn't really interfere with that. Again, we are just the interface. So you're implementing zero trust within your network, and we are literally just passing the user through to you to handle that internally. Where I'm using the term zero trust is in terms of, like, if we are part of that picture, the small part is you don't have to trust us at all. You'll see that you're in control. We can't do anything. We can look at what's going through. We cannot interpret it. We would need the secret off the mobile phone. We don't have that. We'll need the secret that you've got, that you've set up. We don't get that. It's never released. And the other secrets are actually hashed, and who knows what they are or were. So I've gone off on a tangent. I've forgotten the question. Did I answer the question? I'm sorry.
Yeah, you were there. I think I kind of got the gateway. They're two different systems, so that makes sense. So
yeah.
Another question came in from an attendee. So the VM, the virtual machine, has 1FA via 3-character password in the demo.
Oh yeah, I did that deliberately. It actually doesn't matter. It's simply an authentication to my demo account, and I don't care about it. By the way, if you log in there, it's a brand new machine. There's no history. So it actually doesn't matter. There is another demo, which, if you like, I'll just spin us out real quick. No, I've got to get the right screen here. Okay, if I bring this up, I've got so many things open here. Yeah, so this one here, yeah, exactly right. I've got 3-character password. So what the hell is he doing? There's another product here. I'll go to the BankVault website. WebSafe here. We never actually finished the graphics on this. We bet the farm on building this product. It was actually the holy grail. It's such a cool product. It's got about 15 of our innovations in one unified product here. You can see master key at the very beginning there. I'll just scan that. Slight lag here, which I'm not used to. It's normally instant, but we're making changes to the network. I think that's cool. So that's done. That should be building a machine. There we go, up and running. So there we go. There is no single attack surface there. I can do things. I'll just show you a couple more things really quickly. If I bring in over here, this is my file system here. If I go up to my desktop, this is my local machine. I've got a file here. So for example, I can just literally click and drag that into the desktop. So seamless integration, even though this is just running as an image in my browser. I can open this. We're actually building Linux machines here, which is why it's so fast and clean. I can print this off. There's no way I can copy it out of this particular product. We want this to be absolutely bulletproof from any cross-infection or anything. But what I can do is actually print off. I press the print button, it'll actually generate a PDF. If I say accept that, it'll basically just hand that back to my local machine, and I can print it or do whatever I like. There's another thing that I've got in here, which we've built, which is what I call a fortified VPN. So VPN industry is about a $35 billion industry today. VPNs really don't save you from anything, but you're still downloading the same email attachments into your local workstation. You're still opening up that web link in your local browser. It goes straight past a VPN. VPN doesn't do anything. But there's a portion of that $35 billion market that is actually there for security. So this is what I would call a fortified VPN. We've inbuilt a VPN in here. I've got 3 data points here. If I click here, I'm now in the UK. If I run my browser now, I'm effectively in London. I can access YouTube, etc., and it works perfectly. So there is nothing that can actually get out of here. And you can open a virus, it can't run. You can look at a virus in the face. When I get stuff that I kind of need to look at, it's from somebody I know and it doesn't look right. I open up in here. It can't touch me. I'll log off. It evaporates without trace. And the reason that we never finish off the graphics for this, as I said, we bet the company on this. The day that I launched it, we had an inquiry from the local bank here in Western Australia. Could we run our website through this system? Of course, that's what we wanted, you know. And we actually started thinking about this from the point of view. I went to bed that night thinking, well, if the bank has got all the money in the world, and if they gave us all the money in the world, do we really need to have a username and password? I mean, can we just get rid of that? And I came in the next morning. We all have like a toolbox meeting at 7 a.m. in the office here. This is the innovation room I'm in here right now. And I put it to the guys, and we chewed it around for about an hour. And the answer at the end of the hour was, yeah, we could. And it was just like, oh my God. And suddenly I saw the entire world open up. We could actually create a graphical proxy of the web login portal. This is better than a VPN. It essentially is a graphical proxy. There is no way that code can interfere with it or see what's going on. And this ultimately distilled into 2 products. One was the graphical proxy, the other was the invisible keyboard. And the invisible keyboard turned into this product here, which a bank this was actually a mock-up from Macquarie Bank in Australia. So if I look up here, I'm just going to type in a username of Randall. And if you guys want to just scan that QR code with your cameras and then create a password. Here we go. So again, there is no single attack surface. I'll press the login button and we'll just reveal now what actually it received and interpreted. But in my browser, there is literally only asterisks. The password that whoever typed that password is going to the back end of the web server. The web server is only echoing asterisks here. There is no attack surface on my local machine. Let's log in and just see what the back end tells us. Username of Randall, hello, 123. There's the device signature of the phone, 2 factors of authentication. Boom. I'll stop there. I'll just wind back a little bit. And I'll tell you the funny story about how the master key came about. I had an investor in Sydney that loved what we were doing with the invisible keyboard. But he said, look, all my passwords are with LastPass. If you could just do a deal with LastPass, that'd be fantastic. I'll be in. So this idea was rattling around my head for a few years. I'm in San Francisco at the RSA conference in 2020, February 2020, and LastPass had a side event. I thought, oh, I wonder if I can get a ticket. Well, I engineered a ticket. So to set the scene, I'm in a downtown San Francisco rum bar at 5 o'clock in the afternoon with a rum cocktail in my hand, walking around trying to see who's who in the zoo. And then somebody introduced me to the top guy, King Dog, the head of security for LastPass, logged me in. This guy's name is Gerard. I said, Gerard, here's my chance to pitch. You've got a problem. When you load my encrypted password into the web form, it's no longer encrypted. It's now clear text. If there's a man in the browser, it intercepts it instantly. I said, there's nothing you can do to solve that problem, but I've solved that problem. And he looked at me and he said, well, how have you done that? And I thought, Boom, you've just validated everything I've been thinking for the last few years. You can never solve that problem because you're on one single attack surface. You can't do it there. That's why we have two-factor authentication. My trick was using this keyboard that we'd set up in the web server to create a handshake over time, and what resulted in master key. So I won't tell you. Let's trade cards, and I'll tell you later. So I walked out at 6 o'clock in the afternoon. I rang my team here in Perth. It's now 9 o'clock in the morning here. I said, guys, we're going to build a better password manager, and we're going to sell the company to LastPass. So I'm an engineer, they're engineers, and we were like two wheels spinning on the same axle, but independently. And every morning and every afternoon, we'd check in at the same time, and we were all up the same path again, further and further. Every day, it was like, oh my God, we're all in sync. We're actually walking up a path that had never been trodden before. And it was real. And the whole world started opening up ahead of us. It was like, this is applicable to everything. It was so exhilarating. We ended up writing up the patent. We thought it would take 8 days. It took the patent attorney 8 weeks. He called it a beast. We filed it 4 hours before I pitched this at a cybertech event in New York. And it was a lineup of other passwordless startups. And it was hard because these guys were just literally getting their legs cut out from under them. And it was terrifying, actually. I gave my pitch, and we actually won first place. So that was our launch. So it was about, we thought that the market was a $1.3 billion market, and we were carving out a niche of that. It turned out that the passwordless authentication market was 40 times larger. In 2021, it's a $45 billion segment. Our advantage in comparison to competitors, there is no software. It's invisible. You can deploy this in minutes. It's a huge advantage in a massive market. So yeah, that's our story. And I'm probably going over time here in terms of your allocation of time, Randall.
I was going to say, Graeme, we could probably go for another hour or two, but I know it's 3 or 4 a.m. where you're at, and we're at the top of the hour here in San Francisco. So thanks for your time. We really appreciate it. Thanks, everybody. We'll get those CPE certificates out to you as quickly as we can, and we'll see you on April 24th. Talk to everybody later.
Anybody wants to try this, just reach out. Happy to let you use it. Thanks very much, guys.
Thanks, Graeme. Bye-bye.
Bye-bye.